Very often when we're estimating regressions, we have a problem with omitted variable bias, and we need to correct for that omitted variable bias. So there's two techniques, amongst others, but two techniques are commonly used in econometrics and the social sciences to correct for omitted variable bias. The first is called the regression discontinuity, and the second is called instrumental variable. We'll shorthand those to the RD method and the IV method. And we'll work through very quickly these two methods with some specific examples of regressions that we might run. Our first regression that we might run has enrollment as our outcome variable, and whether or not the person was a recipient of a scholarship as the explanatory variable. Our second regression might have the log of wages as the outcome variable and an indicator of the years of schooling, commonly called schooling attainment, as the explanatory variable. So we're interested in knowing whether receiving a scholarship increases the chance of a person being enrolled in school. This is particularly true in developing countries where many families are constrained in by their income and how much they can spend on schooling for children, and so they make hard choices about which child to send to school and which child to keep at home working. And many programs for encouraging schooling rely on giving families cash transfers, or what we might call a scholarship, in order to induce them to alleviate that constraint, that financial constraint that they may have. Of course, many families might not be constrained. They might be keeping their children away from school for other reasons. They don't believe in the value of schooling. They have a social norm against schooling girl children, for example. And so this scholarship in that case may not help, may not change enrollment, or families may enroll their children anyway, regardless of whether they receive the scholarship or not. In that case, the scholarship won't affect enrollment and is just a transfer then to the families and doesn't have the intended effect. Likewise, we're also very interested in knowing the relationship between schooling attainment and the wage. We typically interpret the coefficient beta 1 that we estimate there as the return on schooling, because we have the wage in logs. We interpret then beta 1 as the percentage change in the wage rate, or the income that someone will be earning for an additional year of schooling. So both those regressions are important, they're interesting. We would like to know the plausible magnitudes for the effects here, but we have a problem, and the problem is that there's a pretty obvious omitted variable, which is the ability or motivation of the child, and that omitted variable, which is very hard to measure, how motivated a child is to succeed in school, that omitted variable may be correlated both with the explanatory variable, the scholarship recipient, and whether the child is a scholarship recipient or whether the child goes to school, how many years of schooling they get, and this omitted variable is also likely to be correlated with the outcomes. So ability is likely to lead you to be enrolled regardless of whether you get the scholarship, but it's also more likely to mean you'll get a scholarship. Ability or motivation is likely to be correlated with your income, your wage later in life, but is also likely to be correlated with how much schooling you attain. So knowing that there's this omitted variable and that most likely it's positively correlated with the scholarship or with schooling attainment and positively correlated with enrollment or the wage, we're going to have an estimate of beta 1 that's biased in a positive direction. Beta 1 will look like it's too big. It will look like the effect of receiving a scholarship. It will look like the effect of schooling attainment on wages is too big. The effects are maybe there, but because the scholarship is correlated with ability and because ability is correlated with enrollment, it will look like the scholarship is having a big effect. So we need to correct for that. So there's two methods, RD method and instrumental variable method. The regression discontinuity method applies when we have what we were going to call a running variable that through a cutoff determines another variable, which is often an eligibility variable or some other 0, 1 variable. And we can have a simple example. We may have an index of socioeconomic standing, commonly called SES, and this index may be greater the poorer that you are. So we have some index, some measurement, depending on various criteria of the household about just how poor a household is. The higher the index, the poorer the household is, and this index then we can write down for every household, and we can imagine that this index is what determines whether or not you get a scholarship. So if you're above the cutoff, you get a scholarship. If you're below the cutoff, you don't get a scholarship. Notice that the idea of regression discontinuity is that for some reason the people administering the scholarship have decided that there's going to be a straight-up cutoff. So rather than making the scholarship contingent on the socioeconomic standing, so if you're rich, you get a small scholarship. If you're poor, you get a big scholarship. In that case, the recipient of the scholarship variable wouldn't be a 0, 1 variable. Instead, it would just be a continuous variable for the amount of the scholarship. But instead of doing that, the people administering the scholarship, for whatever reason, decided that it was just going to be 0, 1. If you're above the cutoff, you get a scholarship, so you get the scholarship. If you're below the cutoff, you don't get the scholarship. So the scholarship recipient, which variable, which measures whether you get it or not, is a 0, 1 variable, and it's going to be 0 for everybody below the cutoff, and it's going to be 1 for all the people above the cutoff. And that, knowing that cutoff is then determining whether you get the scholarship or not, so that the variable measuring whether you get the scholarship or not is now basically a purely deterministic function of the SES rank, so that it's not then correlated with anything else. Once you control for the SES score, that enables us to run a regression that looks like this, where we have enrollment as the outcome, we have the SES score as one explanatory variable, and we have whether you get the scholarship or not as another explanatory variable. So SES is definitely correlated with the child's ability, so we don't want to interpret beta 1 as any indicator necessarily of whether your poverty indicates whether you're enrolled, because it might be well correlated with your ability. But whether you get the scholarship or not, this variable, the coefficient on that, will now no longer be correlated with ability, because it's being determined entirely by the SES functions, deterministic. So now we can recover a good estimate of beta 2, of the effect of getting the scholarship on enrollment. So that's one way that regression discontinuity design enables us to estimate causal effect. And there's lots of examples in economics. Just type in regression discontinuity into Google. You'll come up with dozens of examples and papers that are using. This is an extremely simple version. There are more complex versions that are out there in the literature, and it's a really neat mechanism to be looking at, a method to be looking at to estimate causal effects. Let's turn to our second method. Our second method is the method of instrumental variables, and it applies when we have an instrumental variable, call it XIV, that's correlated with the troublesome explanatory variable and does not itself determine the outcome. So we have our equation. The log of wages depends on schooling attainment. Ability is our omitted variable. But we might have some instrumental variable, like whether or not you had a latrine during schooling. That latrine during schooling may have determined your schooling attainment, but would not cause you to have higher income later in life, except through your schooling attainment. So if we have such an instrumental variable, then we can estimate how that instrumental variable, the presence of a latrine, affects your schooling attainment. Then we calculate the predicted schooling attainment, and then we use the predicted schooling attainment in the wage equation, and then the beta 1 that we recover will be unbiased.